All right, let's unpack this. Imagine for a moment a secret held deep within nature, a blend of, ancient wisdom and maybe some untapped potential. Today on the Deep Dive, we're digging into a really remarkable research paper. It takes us from traditional herbal remedies right into, well, cutting-edge science, our mission, to explore how a specific four-plant mixture, one that's been used traditionally for a long time, might actually hold some profound answers for really complex health challenges, specifically leukemia. We're going deep into a fascinating study done in a rat model to, really see what the science tells us. So just to set the scene a bit, as many of you probably know, leukemia is a really challenging malignant blood disease. It's basically characterized by this uncontrolled overproduction of immature blood cells. They kind of overwhelm the healthy ones, throwing the whole body system off balance. And yeah, conventional chemotherapy is absolutely a vital tool, but it often comes with pretty severe side effects, sometimes limiting the dose you can even use. And this reality, well, it naturally fueled this long-standing interest in medicinal herbs. As complementary or maybe alternative treatments, people are drawn to their perceived safety and effectiveness. The big question, though, is how do we move past just perception to actual scientific validation?
Yeah, and that really brings us to the core of it, doesn't it? How that ancient wisdom sort of meets modern scientific inquiry. This study, it focuses on a specific four-plant mixture, and it's got deep roots in Canadian traditional medicine, long reported for potential anti-cancer activity. The key players here are burdock root, the inner bark of slippery elm, sheep sorrel, and rhubarb. You might actually recognize those. They're the foundation for a pretty widely used commercial herbal formula called Essiac. And historically, their uses are incredibly broad. I mean, way beyond just cancer. We're talking things like liver protection, anti-inflammatory effects, powerful antioxidant properties, helping with gastrointestinal issues, even remedies for skin problems and respiratory troubles. It's quite the botanical powerhouse, really.
That traditional range of uses is
Well,
definitely compelling. But okay, making the leap from that traditional wisdom to really rigorous scientific proof, especially for something as complex as leukemia. How does a study even start to bridge that huge gap? What are maybe the biggest hurdles in validating these old remedies?
Well, that's precisely the challenge, isn't it? While we have, centuries of anecdotal evidence and even some in vitro studies, those are the ones in test tubes or cell lines. And those studies showed some impressive antioxidant effects for this mixture, like reducing nasty things like hydroxyl and superoxide radicals by over 80%, and even preventing DNA damage. Pretty good stuff. But what's been less common are the really comprehensive in vivo studies. So studies in actual living organisms, specifically looking at their anti-leukemic effect as a mixture. This paper was really trying to fill that specific gap.
Okay, so how do they actually go about testing this mixture? In a controlled scientific way, but inside a living system.
Right. So they induced leukemia in rats using a chemical called DMBA7, 12-dimethyl benzoanthracene, technically. Then they very carefully prepared the herbal mixture. They made it as a water extract, really trying to replicate a traditional decoction process. This involved quite precise proportions of each plant, like, for instance, 680 grams of burdock root, 120 grams of slippery elm leaves, 455 grams of sheep sorrel aerial parts, and 30 grams of rhubarb root. This whole mix was boiled in distilled water, then allowed to cool, then reboiled, standard decoction, and then it was given to the rats as their drink. That level of detail in the prep, it's actually crucial. It shows a real commitment to, scientific rigor, trying to standardize a traditional method so the results are actually reproducible.
And what happened? Okay, this is where it gets really interesting. What jumped out at you first when you look at the results from these rats?
Well, the immediate sort of observable improvements were quite striking. You see, leukemic rats often suffer pretty significant weight loss, but this plant mixture, it successfully recovered that loss and helped them get back to a healthier weight. And beyond just weight, it actually restored normal total white blood cell counts, lymphocyte counts, and neutrophil counts too. These are really key blood parameters, right? They get thrown way out of whack by leukemia. So seeing them normalize like that, that's a very positive sign.
But the real headline, the thing that truly makes you stop and think, is what happened to the actual malignant cells, the cancer cells themselves.
Absolutely. That was the kicker. The mixture dramatically decreased the percentage of malignant blasts. These are essentially those rogue, rapidly multiplying blood cells that just overwhelm the healthy ones. It decreased them by a remarkable 2/3. That's a 68% reduction in the leukemic rats.
Wow, 68%.
Yeah. I mean, to put that in perspective, it means the very cells driving the disease were profoundly suppressed. That's a huge shift in the cellular landscape. Really powerful.
A 68% reduction is, that's undeniably impressive. But okay, when we see results like this, even really promising ones, in a rat model, what are the immediate questions or maybe cautions that pop into your head as a researcher? Knowing how complex human biology is compared to rats.
Oh, that's a critical question. Always. While these results are incredibly promising, you have to see them as laying the groundwork, right? Understanding the potential mechanism. We still need to figure out exactly what in these plants is doing the heavy lifting. And then crucially, does that translate effectively to human systems? That's the big leap. Now, the researchers did dig into some of the bioactive compounds that are known to be in these plants. So for instance, you've got imidin, which comes from the rue, barb, and sheep sorrel. It's known to put the brakes on a specific protein kinase, CK2, and block cell division. Then there's arctogenin from the burdock root. That one's got antioxidant, anti-inflammatory properties, but also specific anti-tumor activities. It's been shown to inhibit leukemia cells and even trigger them to self-destruct, that process called apoptosis. Plus, you have other components like tannins from burdock and slippery elm and flavones and proquinones. These all contribute. They boost the immune system, act as antioxidants, some have cytotoxic effects. So you see, it's likely not one single magic bullet, but more like a symphony of compounds working together.
That's quite a botanical arsenal working there.
Yeah.
But the study didn't just stop at observing the effects, right? It went deeper, tried to figure out how this mixture was working on a molecular level. They looked at this key player in the immune system, something called sphingosine-1 phosphate receptor 1. Or S1PR1 for short. Can you simplify that for us? What does S1PR1 actually do, and why is it important in leukemia?
Right. This is where the study gets really fascinating, revealing a potential molecular pathway.
Yeah.
So S1PR1 basically acts like a crucial gatekeeper. It guides key immune cells, T lymphocytes, and B lymphocytes as they move around the body between lymph nodes, the thymus, the bloodstream, controls their exit into circulation.
Okay, like a traffic controller for immune cells.
Exactly. That's a good way to put it. Now, here's the thing. In the leukemic rats, this S1PR1 expression was significantly downregulated, massively decreased, actually, by like 14.6-fold.
Wow.
Think of it like those gates being largely shut or stuck, closed. And this is really critical because, well, leukemic cells often do this. They reduce S1PR1 expression deliberately. It helps them trap themselves in these sort of survival niches within lymphoid tissues, places where they can hide out, thrive, and avoid the normal immune surveillance.
So the cancer cells were essentially hacking the system, building their own safe houses by messing with S1PR1. And what did the plant mixture do about that?
Well, this is what's truly compelling. The plant mixture seemed to counteract this. It alleviated that downregulation. After the treatment with the mixture, the S1PR1 expression actually increased significantly by about 8.5-fold compared to the untreated leukemic rats.
So it helped open the gates back up.
It suggests exactly that, potentially unlocking those gates, helping immune cells, maybe including the rogue ones, move normally again. And this could disrupt a key survival strategy for the disease, right? Forcing those malignant cells out of their protective hideouts and making them more vulnerable. It suggests a pretty direct molecular pathway for how the mixture might be working.
Okay, so pulling all this together, what does this research really mean for you, our listener, thinking about natural approaches and leukemia?
Well, I think this study provides some pretty strong scientific backing for those long-held beliefs about the anti-cancer effects of this specific four-plant mixture, particularly in the context of leukemia. It moves us beyond just anecdotes or, simple cell line studies into solid in vivo evidence in a living system. That's a big step. The researchers also pointed out beneficial effects on the overall immune response. For instance, other studies on Essiac. Remember, the commercial version based on these plants have shown it stimulates CD8+ cells.
Those are the killer T cells, right?
Oh, exactly. The immune system's targeted assassins, critical for identifying and destroying diseased cells. And maybe most importantly, the mixture showed greater toxicity towards the cancer cells compared to normal, healthy cells. That selectivity is absolutely vital for any potential therapy. You want to hit the bad guys without too much collateral damage. So this kind of rigorous research helps us move from just saying, oh, it's good for you, to actually starting to understand, okay, here's how it might be working.
And that pretty much wraps up our deep dives into this remarkable four-plant mixture.
Yeah.
We see how it showed significant promise, at least in this rat model of leukemia. It impacted everything from, physical symptoms like weight loss and those crucial white blood cell counts, all the way down to specific molecular pathways like that S1PR1 gatekeeper, which plays such a critical role in how immune cells move around. So as you go about your day, maybe just consider this.
How often might the answers to really complex health challenges lie, not necessarily in one single isolated breakthrough, but maybe in the intelligent synergy of compounds found right there in the natural world. Compounds just waiting for us to truly understand their deep, intricate mechanisms. Keep that curiosity alive, everyone, and we'll catch you on the next deep dive.